Friends, very good morning to everyone. We were dealing with peptide synthesis. We know that we have two strategies of synthesis. One is solution phase synthesis, which is the traditional and old method. Another is a solid phase synthesis. In solid phase synthesis, we said that we use a solid support. Today's subject of discussion is what are the serious solid supports available in this market? What are their limitations? What are their utilities? And how these solid supports are linked to the amino acid? And which are the type of linkers used? And how much are the types of linkers available in the market? What are their salient features? Is the subject of discussion for today's class. The solid support, what we use, generally be present as a bead. These are the beads made up of polystyrene. The average diameter of these beads is around 50 micrometers. These beads are either soluble in DMF or DCM, dimethyl formamide or dichloromethane. It is not exactly soluble, it is soaked in DMF or DCM, where it absorbs the solvent and it swells 2.5 to 6.2 folds in its volume. And this helps in to move the reagent through this, and that combines with the functional groups present in it. SPPS synthesis, so that is solid phase peptide synthesis, takes place in this solvated gel which contains the reagent and the mobile phase. And this swelling makes the reagent accessible to the peptide chain. Generally, small particle sized resins with low cross linking are used as it allows rapid diffusion of reagents inside the beads. Solid support and the peptide backbone, the polarities are comparable. Generally, the solid support has polyamides or polyethylene glycols or the copolymer of these. Four types of resins are available in the market. Chloromethyl or aminomethyl polystyrene resin is the first variety, and this consists of 1% divinyl benzene cross-linked polystyrene. This is a polystyrene cross-linked with 1% divinyl benzene. The functional groups present in this polystyrene resin is either chloromethyl, aminomethyl, or benzhydryl amino group. Another resin is tentagel resin. This is having polystyrene grafted with polyethylene glycol. That's it is called as polystyrene polyethylene glycol graft polymer. The functional groups present in this tentagel resin are either COH or NH2, SO3H, etc. Pega resin, it is also called as PEGA, stands for polyethylene glycol acrylamide. It is a polyethylene glycol dimethyl acrylamide copolymer. The dimethyl acrylamide is copolymerized with polyethylene glycol. It has methyl amino group as the functional group. The last type of resin is Nova gel resin. It is having 4-O-methyl polyethylene glycoxycarbonyl methyl polystyrene. This also has the functional group similar to PEGA, that is methylamine. These solid supports or these resins are should be handled with care while usage. The first thing what we do when we take the resin, we add into either DMF or DCM and make it to swell. All these are swollen before connecting with the amino acids. Pega is the exception. It do not require the swelling. Underatized polystyrene resins swells only in dichloromethane, whereas other derivatized polystyrene resins swells in DMF. That's why accordingly we have to choose our solvent system. Except Prega, all resins can be dried under vacuum without getting damaged. This can be reused number of times after drying in the vacuum. Resins are very sensitive and fragile. That's why it should be handled with care. We cannot use a magnetic stirrer and stir it because resin will get damaged. These are the care which we have to take while using this resins as the solid support. Various linkers have been used. This linkers first type, second type and third type. Three types of linkers are available. What is the purpose of this linker? This linkers links the amino acid with that of the resin. In other words, they are the functional groups which links the solid support with the amino acid. And these linkers are reversible linkages. They are not permanent. It can be cleaved. This links the carboxy terminal group of the amino acid with that of the solid support. Upon cleaving with trifluoroacetic acid, this less cleaved to give rise to peptide acids or amides. Some of these linkers permit cleavage in the presence of nucleophiles. And it gives C-terminal modified peptides like esters, secondary amides, aldehydes, alcohols, etc. The first type of linker is hydroxymethyl based linker. It has hydroxymethyl functional group. This is called as Wang linker. This has hydroxymethyl phenoxy group. The phenoxy oxygen links with the resin and the alkoxy oxygen links with the peptide. It links the peptide with the resin. Resin is represented in red color bead. There is another linker, it is called a Sasrin linker. This is also similar to Wang linker, but this Sasrin linker is SAS. SAS stands for super acid sensitive resin. It is sensitive to super acids. This is having the same hydroxy methyl phenoxy group at which in which ortho position there is methoxy group. This is prepared by treating orthomethoxy parahydroxy benzaldehyde with Merrifield resin which has chloromethyl as the functional group. This OH phenoxy group gets linked with this. This is the positive center. OH has lone pair of electrons, attacks over here. HCl gets relieved and I'll gets linked with this thing. And then I reduce this aldehyde with sodium borohydride to get CH2OH which links with the amino acid. This is how we prepare this saccharin linker. HMBA linker. HMBA stands for 4-hydroxymethyl benzoyl amino methyl polystyrene. To the polystyrene resin, hydroxymethyl benzyl oxy amino group, benzyl oxy group is attached. Another linker is zinc acid linker or zinc resin, we call it as, or NOR linker is another name. Here it has trialkoxy benzhydryl alcohol as the linker. The second type of linker, this is also super acid labile like that of saccharin linker. Another set of linkers are trityl chloride based linkers. Triphenyl methyl chloride. Trityl chloride means triphenyl methyl chloride. The first variety is 2-chloro-trityl chloride. The second is Bayer's carboxytrityl linker. It has trityl methyl alcohol at the one end and the other end it is having carboxy group. The third is aminomethyl based linkers. As the name indicates, it has aminomethyl group. There it has hydroxymethyl group. Here this is aminomethyl group. The first one is ring linker. It is what we have seen in ring resin in case of hydroxymethyl derivatives. There we had CH2OH. Here we have trialkoxy methyl benzhydryl amine. There we had benzhydryl alcohol. This is aminomethyl based ring linker. Another is Paul linker. Paul is photo affinity labeling linker. This is having trialkoxy 1, 2, 3 alkoxy groups, trialkoxy methyl benzyl amine. Photo affinity labeling linkers are used to study protein-protein interaction using a light activated probe. Next is Sieber linker. It has 9-amino xanthinyl linker. These are the three varieties of linkers available in the market which are used to link with the resin and the amino acid. In the next presentation, we can deal with the strategies used for synthesis of peptides. Varieties available with examples. Till then, have a nice day. Thank you.